okay, guys. I think. I think all students have a chance to return. Okay, guys, any quick questions? Monday next week is our last class meeting, regular class meeting. Next Wednesday, I'll just let you guys know, I'd like to come back in on campus, even though we don't have class, and do this review session. I'll let you know the time and all that business going on. Now, with all that said, I look at my notes and I see I got tons of things got to do. I have handouts. Let me check and see what we got here. One handout that you're going to receive tonight are some review topics for the final. So I went through and gave you some topics and maybe some examples to look at. This goes all the way back to the difference quotient, complex zeros, sketch the graph of a piecewise defined function. Remember doing all that? I'll just give you a little reminder. So I'll get this to you before you leave tonight. We'll review topics for that final coming up. Okay. Guys, any concerns? Mr. Bart? Anna, anything at all? No? We're good then? Got any concerns? Now, here's what I got to do. Michael's going to help me. We have, to finish up chapter 6 tonight, we have formulas after formulas after formulas. I hate to use the word memorize, but you have to know these formulas. Michael, remind me before I ask you a few questions here. How many handouts did I give you guys?
2.
Besides the A plus B, A minus B, sum and difference formulas, what else was on there?
Sections 6.
And that was the double angle. So you have not received the half angle formulas yet. That's what I have tonight, so we finish up. Now, Michael, what I want you to do is, even though we have a handout, please tell me sine of A plus B, the sine of the sum of two angles. What formula should I use?
Sine A.
Sine A, cosine B, and?
Plus cosine A, sine B.
Plus cosine A, sine B. Okay, next one I think was sine A minus B. Hey guys, all this is on your handout, I want to make sure they're here. Sine A, cosine B, minus cosine A, sine B. And as you memorize these, my goodness, if you know one, you'll know the other. Just a little sign change. Michael, did I mention now cosine A plus B? All formulas. And it starts out with, I guess, cosine A, cosine B. Was it a minus this time?
Yes.
Sine A, sine B. Let's do D. Cosine A subtract B. The difference. So cosine A, cosine B, plus sine A, sine B. Guys, you cannot move into a calc, of course, unless you know, in case you have to use them, these formulas. Michael, please remind me, were those the sine A plus B, cosine A plus B, A minus B formulas listed? That's it right there.
That's it.
Okay. So guys, that's one set of formulas, and more than likely on the handout I had some exercises to try. Did I? Like what? Remind me.
Sine 7 pi over 12.
Okay. Sine of 7 pi over 12. Now you guys who like degrees could quickly convert that into degrees. I'm checking it out myself. I think it's 105 degrees. I think it's 105 degrees, which is not one of those angles you're accustomed to. I'm accustomed to 45, 60, 30, 90, but they're asking me to find that without a calculator. Sine of 105 degrees, 7 pi over 12. How am I going to do it? I hope to come up with a combination, an A and a B, two angles that we do know something about, that somehow I could either add or subtract and come up with 7 pi over 12. Does anyone have an idea? How could I rewrite 7 pi over 12? And there may be different ways to do it. Does anyone have an idea of how to come up with two angles that we are accustomed to, that maybe I could add and get 7 pi over 12, or subtract and get 7 pi over 12, and try to come up with sine, or 105 degrees? What do you think? Yes?
2 pi minus 7 pi?
Okay, 2 pi, that's 360
Or
minus.
pi.
Okay, pi, try to, I don't think that's gonna work. I'm trying to do math in my head here. Now guys, what angles are you accustomed to? Pi over 4, pi over 3, pi over 6, pi over 2, pi, 2 pi, those types of angles. Now can anyone give me maybe two here, an A or B, so I can get one of these formulas that either adds up to, I hope you can find A plus B, that would add up to 7 pi over 12 or add up to 105 degrees. Yes?
Pi over 3 plus pi over 4.
Pi over 3 is 60 degrees, pi over 4 is 45, she's got it. So pi over 3, pi over 3 plus pi over 4, Melanie thinking. If you add those up with the common denominator of 12, guys, it gives you 7 pi over 12. Now, if you make that now look like this, therefore sine of 7 pi over 12 can never be discovered, found if I use this formula. That formula says take sine of A, in my case sine of pi over 3, right next to it, cosine pi over 4, plus cosine pi over 3, sine pi over 4. I use this formula here. Guys, plugging the numbers here from the unit circle. Now, this should, we also know sine of pi over 3, sine of 60 degrees, radical 3 over 2. Check back on the unit circle. Cosine of pi over 4, radical 2 over 2. Cosine of pi over 3, we'll find that to be 1/2. And sine of pi over 4, another radical 2 over 2. And therefore your answer is going to be, and I'll do it fairly quickly, it's going to be radical 6 over 4 plus radical 2 over 4. Better expressed as, put them together, radical 6 plus radical 2 all over 4. And there's your final answer for the sine of 105 degrees with the help of the formulas. You're done. I would not ask you to estimate that. Finish. Okay? Michael, tell the class what else did I have on the handout that somehow connects these? What else did I ask?
Cosine 5 pi over 12.
Okay, now cosine 5 pi over 12. Here goes, guys.
There's more to it.
Oh, there's more to it. And
Times
Oh,
cosine
times.
7 pi over 12.
times, how much now?
7 pi over 12.
Cosine?
Mm-hmm.
Oh, I got you. 7 pi over 12.
Minus sine 5 pi over 12
Got you.
times sine 7 pi over 12.
Got you. Okay, guys, the reason I placed that one on the handout is you take a close look at it and try to match it up with one of these formulas on the side here. I think, let me check and see if I don't get the wrong one here, is it this formula here? That's what fits. So we'll use cosine, and by the way, this formula right here, all that he's given me, since it fits the formula, is equal to cosine A plus B. So I quickly say, Professor, without going through all this, this is equivalent to cosine A plus B, in my case, 5 pi over 12 plus 7 pi over 12. And guys, that's going to give you cosine of 12 pi over 12. Let me go ahead and call it pi, which takes you right to the unit circle. I had no mistake there. Guys, what is the x-coordinate cosine at pi for an answer?
0.
Ah,
Oh, 1.
negative one. There's the answer. Done. With the help of the formula. If I ask Park to do this, which I'm not gonna ask him to do it though, he could actually go through, since he has a calculator, he could find the cosine of 5 pi over 12 quickly using the calculator, cosine 7 pi over 12, and you could do it with the calculator. In the end result of the calculator though, you'll get negative 1. So this is where I just use a formula. Okay, Michael, let's try to close this down, and what else did I add? Was that all I had there, or not, something else?
Oh no, there's 5 problems.
Oh, tell me what the third one is.
Cosine,
Okay,
bracket,
here you go.
inverse tan,
Uh-oh.
4 over 3,
And 4/3,
minus inverse cosine,
inverse cosine,
5 over 13.
5/13. Guys, now this is gonna be a workout. This one's gonna be a workout. But we're gonna do it. If I ask you right now, which of these formulas on the side here might just fit, I would hope you'd say, well, Professor, it looks like it would be cosine A minus B would be the formula I would try to use. Therefore, that takes me over to this formula. So I need to fill in this formula. Now the formula says if you want to use it, you gotta find cosine A, I'm gonna put it right here, cosine A, cosine B, and it looks like it's plus sine A, sine B. And if you step back and look at it, make sure we have the right formula there. You guys agree? So if you want the answer, you gotta find that. Now, Michael, the interesting thing here is in class, if I got to use this to get the answer, all of a sudden they throw a tan at me. There's no tan mentioned over there. Something interesting is going on, even though this does look like cosine A minus B. So you guys, here we go. You translate this. Anyone tell me what inverse tan 4/3 means? But if I actually try to find what it is, just tell me what it means. If I say, what's the inverse tan of 4/3, in your mind, what do you see?
Sine 4 cosine 3.
Tell me again.
Sine 4 cosine 3.
Oh, I got you. Now, see, you're saying, well, y over x. I see exactly what he's saying. He's saying sine over cosine. Professor, that's tangent, sine over cosine. So sine should be 4, and cosine should be 3, and I've matched it up, Professor, some way. And guys, sine, see exactly what he's thinking. If I say sine is 4, I think the highest sine goes is 1. And that's the highest value sine goes up to? Just regular sine? So I can't use that. Something else. Let me put it on the side here. Suppose you had this. I'll just do this for you. Suppose I ask you, what's the inverse sine of 1/2? Tell me what the answer is and how you think about it. And we'll get back to this one. If I walk up to you and say, what's the inverse sine of 1/2? You would respond with?
5 over 6.
I heard pi over 6. Now, Michael, why pi over 6?
It's the y coordinate of 5 over 6 on the unit circle.
Okay, so are you telling me, in essence, if you take sine of, not inverse sine of pi over 6 on the unit circle, is that 1/2? That's what the statement says. So he's correct. So inverse sine 1/2 is pi over 6, 30 degrees. And why? Because if you take sine of 30 degrees, pi over 6 is 1/2. Now this one, can someone translate for me? Even though I can't find exactly what it is on this one, but you can tell me what it means. Can anyone translate this one? Inverse tan 4/3, and I have an A right above there. Anyone tell me what it means? Michael, translate this one for me like this. Anyone tell me what this one might mean? Oh, wow. what this means. He says this means this, I agree with him. What's this mean? This one mean? I'll get you started. That means you're gonna take the tan of an angle, A, and you're supposed to get 4/3. That's what that means. I don't know what it is. It's one of those, it exists, it's not one of those nice ones like he gave me on the unit circle over here. This one, if I translate it, guys, here goes. Can anyone tell me a translation for this one where it says inverse cosine 5/13? Keep in mind what he did for me here. Can anyone tell me what that means? And I've got an angle B associated with this one. Can anyone tell me what it might mean? Or should I go ahead and do it? Does it mean cosine B is equal to 5/13? That's his translation. So we got that much. Hey, guys, you mind to find the answer? The formula says to find the answer, you gotta do this. You gotta put in replacements. Guys, the only replacement I see right now that I can actually put in if I wish, cosine B is what, 5/13? I can put that in right here. This is a nice problem. It'll make you think a little bit. 5/13. I put that in. Cosine A, I have no idea what it is. Sine A, sine B over there, I don't know what it is. I know what tan is. Now, can someone help me? How can you find any of those three missing? Because I gotta find cosine A, sine B, put those in, formula, and calculate and get the answer. If you want to have an idea, how can I use what I have, maybe, to get to the missing parts of the ring?
1 over sine,
Do it again.
10 over.
I love that. Tan is what? Sine over cosine. So again, we're gonna run the same problem here, though. If you say sine over cosine, which I love, Jonathan was thinking the same thing. You're saying sine is 4, and sine cannot be 4. Maximum for sine is what? 1. That might take something else. Jonathan, help me.
Sine squared plus cosine squared.
So each one uses an identity. If you want, let me use it right here first. Jonathan, read. He says, Professor, sine squared b, I'm gonna do b first, plus cosine squared b gives me a 1. That's true, guys? And then I can write this as sine squared b, here we go, plus cosine squared b would be 5/13 when I put my replacement in there, squared is equal to 1. Cosine b is 5/13. I got to solve this, so I end up with sine squared b. I'll do it fairly quickly here. This is 25 over 169 equals 1. Just going through the math here. Sine squared b. If I subtract 25 over 69, in other words, it should be 25 over 69, didn't move it over. Put those two together, I messed up here,
144, negative 144.
was it negative 144? Yeah, I've got two, why do I have two equals marks here? What did I do here?
25 over 169 minus 1?
Yeah, right here, it's what, be 1 subtract? Was that it right here? 1 subtract this? Help me out. Tell the board here. See what I meant?
Mm-hmm.
Let me erase this. I'm gonna approach it some other way there. Guys, by the way, with what he gave you there, is that it? Move this over, so it's gonna be 1 subtract that. Common denominator 169, 169 subtract 25. My goodness, all the math involved here. Taking a lot of time here. That's 144 over 169. That's just doing math there. Take a square root, we hope. And here may be an issue. We'll see. Sine b, if I do a square root, thank goodness, 144 over 169 is perfect. It's plus minus 12 over 13 if I do a square root. Is that true, guys? Whew. Now, looks like I can take that up here where it belongs. This is a lengthy problem. So we just found another replacement. I'll put it in eventually. With Johnson's help. Sine squared plus cosine squared is equal to 1. This thing is work. This, guys, is more like an extra credit type problem. I had to show it to you. Now, is it going to be a plus or a minus? Where's B located? It says inverse cosine 5/13, and I'm calling that B. That's an angle. So I got cosine B is 5/13. Inverse cosine, does anyone remember the restriction on inverse cosine from last week? 0 to pi. That's true, guys? From 0 and pi. And what cosine am I looking at? I'm looking at a positive 5/13. Now, if you go from 0 to pi, please, is that quadrant 1, quadrant 2, that you would be located? If you go from 0 to pi, I need a circle. Are you covering quadrant 1, quadrant 2? Right. And they gave me cosine to be a positive 5/13. I am in quadrant 1. If I go to quadrant 2, cosine's negative. Look at all that thinking. So I'm in quadrant 1. If I'm in quadrant 1, we've lucked out. Sine is positive. So finally, when I bring it up here, guys, it's 12/13. We're hoping in this long, drawn-out problem. Now, I got cosine A, sine A remaining. Does anyone see anything at all I could do here in an attempt to find either cosine A or sine A? All I know about A is tan A. And I can't use sine is 4 and cosine is 3. I wish I could, but I can't. Does anyone have an idea?
Secant squared equals 1 plus.
1 plus tan squared is equal to secant squared. That's where the mistakes me. 1 plus tan squared is equal to secant squared. And you guys have seen this identity before. That means, Michael, this is 1 plus, if I use that you gave me, it's 4/3 squared, right? Equals secant squared. Look at this problem. 1 plus 16 over 9, no problem. Math here. Put those together with the common denominator of 9. Guys, what's that, 25 over 9, I think? Interesting, secant squared A. Take a square root, at this point it's plus minus 5/3 equals secant A. Ooh, did we decide that we were in quadrant, oh, by the way, is this right here going to be in quadrant 1 also? Think about where is A going to be located, is tan positive in quadrant 1? I've got a positive 4/3. So if I'm in quadrant 1, I can erase that negative, can't be negative. Michael, you said 1 plus tan squared is equal to secant squared, I love it. I need a replacement for this.
Yeah, secant A is equal to the inverse of cosine A.
Okay, so could I say this? Could I just quickly flip this over, call it the reciprocal, and now call this cosine A? Is that the relationship between secant and cosine? Are they reciprocals? Therefore, now I have a replacement for, look at this, cosine A. Lord. Now, where's sine A? That's the only replacement I need to finish up. Where's sine A? How can I find sine A? That's the only part missing is sine A. I know cosine A. Anyone have an idea how can I find sine A? I'm running out of board space already.
Sine squared.
I can use the same thing here. This time sine squared A plus cosine squared A is equal to 1. If I do, it's going to look like this. And guys, I'm careful with this black marker here. Cosine A is 3/5. I'm going to put that in there. 3/5 squared equals 1. And this is sine squared A. Jeez. Do the math. Let's do the math right quicker. This is sine squared A is equal to, you're going to end up with 1 subtract 9 over 25. 1 subtract 9 over 25, I think it's 16 over 25. Please, don't make a mistake. do a square root, we're in quadrant 1, thank goodness, this should be a positive. Is that 4/5? I did that real quick. You guys agree? Woo! For a Monday. So that finally means I get to put in 4/5 here. And of course, plus sign there. And now let's get the answer. The answer is going to be 15 over what, 65? Plus 48 over 65. It's about a strange answer. 15 plus 48, guys, help me out. Is that 63? So the answer is 63 over 65. And I think if you check out Park's answers he sent out, he got the same answer. I see some looks on this Monday like, whoa, Professor, you're going to open up Monday with this? That make sense, guys? That's a good mix of the inverses with the formulas. Okay? Mr. Park, do me a quick favor, because I got really rushed tonight. They would not be asked to do this, but I'm checking. Could you find inverse tan 4/3? Actually find the angle for me. Do inverse tan 4/3 on the calculator and tell me what the calculator shows for the size of the angle. It's a curiosity, guys. How much is that?
53.
53?
Yeah.
Hang on now. Oh, I was going to use it. Hang on. 53 degrees, we think. I certainly did not know that. 53 degrees. Subtract now do inverse cosine 5/13. Let's see what that angle is.
67.
How much?
67.
67.
Yeah.
And Park, if I subtract 53, subtract 67, that's in the green, that's a negative how much, guys? 14? So negative 14 degrees. So now find cosine of a negative 14 for me. Show me what the calculator shows for an approximation for cosine negative 14 degrees.
0.97.
0.97. Now, we got this for an answer. See what 63 over 65 is.
0.97.
It checks. Jeez. Are we going to be ready for this final exam? Oh, I hope so. 3-hour exam. Okay, guys. Now, Michael, I'm hoping you'll tell me, is that the last thing? You said there were 5 problems. Tell me what the next one is. Maybe I need not do it after that lengthy thing there. What else is there?
Similar, sine, bracket, inverse sine.
Okay, let's leave that one now. Park sent the answers up for these guys.
Tan 7 pi over 12.
Okay, here we go. Guys, I'm all over the board here tonight. Jeez. Tan of 7 pi over 12? Here we go. Now, when we do it by formulas, guys, like an A plus B or an A minus B, 7 pi over 12, if you want to convert it to degrees, might be better for in degrees. Does anyone know what 7 pi over 12 is if you convert it? Which might be better. In fact, did we have 7 pi over 12 earlier? Oh, we did. Except over here we're taking sine of it. Oh, that was 105? 105 degrees. Here they want tan. Michael, please tell me, was there a tan formula listed? No. What are you going to do as a clever student? I didn't give you a tan formula. The textbook may have. Can anyone be creative and clever and tell me how you're going to find tan of 105 degrees? We found sine over there. What could you do on this Monday without trying to memorize another formula? Do this. Sine of what? 7 pi over 12? Over what? Cosine. 7 pi over 12. Let's change it. Sine we found. Thank goodness, we got radical 6 plus radical 2, I hope this is correct. All over 4. Guys, have we found cosine 7, 5, or 12 somewhere on this board? But I don't want to go through it, but I don't have to. I don't think we found it, did we? Did we find cosine 7, 5, or 12 anywhere here? Because I need it for the bottom part of this.
We did.
Did we do cosine? 7, 5, or 12? I see 5/13 and 4/3 and, over there.
No, we didn't.
I don't think we did. So that means you'd have to find what, cosine 7, 5, or 12? You want to finish this up, this one up, guys, and then leave that part there. Okay, now help me out here. Guys, this one's missing. Let's find it by taking cosine of, what's a good combination, what can we use over there? Pi over 3 plus pi over 4. And cosine A plus B formula would have to be used. I gotta be careful. A plus B, I'm looking at it over there. That would be cosine, why they work out tonight. Pi over 3 cosine pi over 4 minus sine pi over 3 sine pi over 4. We gotta get through all this tonight, which we will. Cosine 60, guys, radical 3 over 2. Cosine of 5 over 4, radical 2 over 2, all that's just a unit circle. Sine of 5 over 3 is 1/2. And sine here is radical 2 over 2. I think we got all that correct, let's hope so. This cosine 60, is it, guys, help me out here. Cosine 60 is how much? How much is cosine 60? Is it 1/2? Is this 1 over 2 here? And down here, then, this one must be radical 3 over 2. I gotta watch this myself. Radical 3 over 2. Let me get a circle. If that's correct, you're gonna end up with radical 2 subtract radical 6 all over 4. Oh, my goodness. Is that true? Now, make this up. We have cosine of this. This is a replacement. I can put down here. So this is radical 2 subtract radical 6 all over 4. Now, guys, no more confusion. Look at it. They're lengthy, worked out. Now, this is what you're supposed to simplify to find tangent. This is sine over cosine. 4's will cancel. Now, can someone tell me why would Randy place this on the handout? Because you're not going to leave the answer like that. 4's do cancel. Those radicals cannot stay. You got to rationalize the denominator. Can anyone come up with a good plan as to how to get rid of those red radicals in that denominator? And keep in mind, there's 2 radicals this time. Be careful, not 1. If there's 1, it's easily done. But there's 2 this time. And my students who were with me at 4 o'clock, I think we saw something like this. Anyone have an idea how can I do something here, the 4's are gone, and clear those red radicals out? Rationalize. Any ideas? Go for it.
We like, factor out the negative one on the bottom, like, if you count.
I could, but you think it's gonna match up with this? No, it's not gonna match up with this. I wish it would match up with this and that everything would cancel. Nothing's gonna match up, so nothing's gonna cancel. I cannot leave those red radicals where they are.
Can we multiply by the same?
Do it again.
Can we multiply?
Multiply by, oh, here goes. Multiply by what?
Same, like, 2.
Radical 2?
Radical 2 minus radical 6.
Not radical, not minus. Almost.
Oh, plus.
It is gonna be a plus. Top and bottom. Look at this mess. She's telling me now, Professor, you multiply that bottom part out, denominator, the radicals will drop out. Let's see if they do. You guys, you multiply these two together. This is almost like taking A subtract B. You guys at 4 o'clock saw us do this. Times A plus B. Is it true? Which is merely A squared minus B squared. One thing like that, that's what it looks like to me. A squared is radical 2 squared. I'll put that in just to show you what's going on here. Minus B squared, that's radical 6 squared. And of course, you still have on top this mess. These can get messy. Now, please tell me, with this right here that was suggested to me, will that now clear it out? I think we end up with 2 subtract 6. No radical, -4. Oh boy. Now what's on top? If I multiply this mess out, guys, it might be wise to rearrange it. I'm talking about a workout here. Just rearrange it. And then multiply that out. Some of you guys use the word FOIL. Multiply that out and do it fairly quickly. We'll end up with square root 36, which is 6. We're going to end up with a radical 12. Oh boy. Another radical 12. And last time last, a radical 4, which is 2. Now, did that quickly? Let's just multiply them together. Algebra. Let's hope I have no mistake. I hope not. This is 2 radical 3. What a workout. This is 2 radical 3. So guys, at this point, I have 8, 6 plus 2, these 2. And my radicals put together, 2 radical 3, 2 radical 3 is 4 radical 3. And that goes here. Let's hope we don't have a mistake. Aaron, does it look good so far? Okay. Now, can I clean this up? I could take out a common factor of 4. Guys, we'll have this left over a -4. There's a little factoring on top. The 4's will cancel. I'm left with that negative sign, so it looks like the answer is going to be a -2 minus square root 3. Oh my goodness. What a Monday this is going to be. Now, I'm leaving the A plus B, A minus B, that type of business here shortly. We'll get into, I think it's called double angle formulas next. Mr. Park, do me a quick favor. You want to do a good job of closing all this down tonight. Would you go ahead and find what the calculator shows for tan of 7 pi over 12? What is that? Yeah, directly put it in.
-3.73.
73?
Yeah.
-3.73, guys. We got this answer. Would you approximate this for me?
Yeah. -3.73.
-3.73?
Yeah.
Same thing. So feel much better about it. Brianna?
If we had sign, could we use an identity to make it quicker?
Okay, like, what did you want to do? With an identity, I love identities.
Like we could have found cos with sine squared plus cosine squared.
Oh, I got you. Absolutely. Sine squared plus cosine squared is equal to 1. Use that, and then put sine over cosine.
Yeah.
Beautiful. You could. Absolutely could. Different ways to do these. Guys, the board is full. So one set of formulas are done. A plus B, A minus B. Is that true, Michael? Now, before I leave you guys, I'm not going to do anything else. No, I want to point this out. If you're asked to find, let's say, sine of, okay, what do I want here? Before I leave all this. Pi over 12, I don't think we've had a pi over 12. Now, I'm going to fully work that out. Sine of pi over 12. I don't think I have a pi over 12 over there. And I will use a formula listed on the board. That's 15 degrees. You've never worked with 15 degrees ever in here. A lot of students say just take half of 30. That doesn't quite work until you get a half angle formula. We're not doing half angles yet. Can anyone tell me what nice combination could I use here in the attempt to use one of these formulas? back here, you get the answer. And I'll just set that for you. That's 15 degrees.
It's 45 minus 30.
Love it. Who said that? Love it. 45 subtract 30. So she said, Professor, rewrite like this. Sine 45 subtract 30. 5 or 6. And put those two together with a common denominator of 12, you definitely will end up with, thank you so much, that's 5 or 12, isn't it? And then what you would do is use sine A minus B, this formula. Finish it up. Okay, guys. I know, I see looks on faces like, will I survive? Am I gonna finally get through all this? Cindy, it's gonna be a challenge for all of us, including me. Okay, Michael, please flip that over. Now, you guys have a copy of this handout already. Is the next page now a new set of formulas called double angle formulas?
Double angle and half angle formula.
Thank you. Were the half angle formulas listed?
I'm not sure which one's which.
They weren't. Okay, so let's do this. Get all this done. Part 2. Gee, what it worked out here. Thank goodness I have those worksheets. Handouts. Okay, guys, he says, Professor, there's another set of formulas. I think all this is part 1, all this part 2. He says there's another set of formulas known as, here we go, double angle. I know all these, and when to use them. Okay, Michael and Glass. If we start out with sine double A, 2A. Is that the way it starts?
Sine 2 theta.
2 theta, oh, okay, call it theta. Sine, 2 theta. Double theta. We would like to have a formula. Now, the formula's listed on your handout, right? Let me show you real quickly this from where it came from. Can anyone in this clever class tell me? Suppose I ask you to derive, show me where the formula on the handout came from at this point, based on something I just erased. We'll sine double theta, be clever, and use something we just recently did, apply it, and we'll get the formula listed on your handout.
Sine theta plus theta.
There you go. Sine of theta plus theta. He has given me this. He says, Professor, use sine A plus B. I'm not going to do that sine A plus B formula, guys. And I have all those formulas listed, so I'm going to do it quickly. I apply the sine A plus B formula, it looks like this. Sine theta, don't let me mess up, cosine theta, plus cosine theta, sine theta. Looks a little unusual. Is that what it looks like if I apply a formula? Sine A plus B. Now, Roberto, if I look at that, I think I applied it correctly. Can you tell the class, if I take a close look at these two terms, what about those two terms? Are they alike? Just turn around, one just turn around? Are they alike? Like x, y is the same as y, x, right? So if I combine them, I can call this, I have 2 of these. Just combining like terms. Michael, please tell the class, is that the formula they have listed?
Yes.
That's where it came from. Now you have a double angle formula for sine. Michael, I don't know exactly on that handout, did I now jump into part B? What, did I give you the cosine? Okay, there you go, cosine double angle.
Cosine 2 theta.
2 theta. Guys, here goes. I'm gonna write like this, cosine of theta plus theta. This is mathematics. That's 2 theta. This one now will take the form of something I just erased that we discussed. This takes the form of this that we just looked at. I now need the cosine A plus B formula. I need to apply the cosine A plus B. Guys, if you apply it, you know when you mess up, you're going to end up with cosine theta, I think it's a minus, sine theta. Guys, please tell me, is that the application, did I do it correctly on cosine A plus B? Cosine A, cosine B, minus is it? Is it a minus? Yeah. Okay. Better yet, out front is cosine squared theta. Now on the end, minus sine squared theta. Michael, please tell me, is that a formula I have listed for cosine double theta?
Yes.
Yes. Now, there's other versions. So I think I in fact, even listed the other versions. I know some of my students in this clever class, anyone who could get that math 8 problem to work out for extra credit on that exam, I've got a good class to work with. I had 3 students, I didn't think anyone would get it. I had 3 students who got that extra credit on that test, that math 8 problem, correct. Now, can anyone tell me if I ask for another version, what could I do with the one you see blocked off? Just play with it and come up with another version. I'll give you a hint. I'll put it right here. Here's a hint. We all know this. All know this. Now, can I apply the green somehow, go back to the red, and rewrite the red? Who has an idea? Let me do it quickly. If I know this, and we all know it, guys, I could easily write this as sine squared theta. Move that cosine squared over, and have this. Is that true? And then take this, look at this, take this in the green and substitute sine squared up there with it. I'm going to make a substitution. If I do, here we go. I'm going now right next to it. Guys, here goes. Don't let me mess up here. This is going to be cosine squared theta, subtract, and in place of sine squared, we'll put the green. 1 minus cosine squared theta. Clean that up, some sign changes, you'll end up with 2 cosine squared theta minus 1. There's another version. Okay, so I started out with this one, I think I did. I converted to that, which is going to be used. And I see one more thing we could do for clever, to come up with one more version. Who has an idea? Okay, you can use this one, that's a formula. Or if you wish, in certain cases, it may be easier to use this one for your formula. And all this is for cosine double theta. And I'm putting in another color, there's one more version. What can I do? Go back here, does someone have an idea? To rewrite and have another version. Any ideas? Okay, let me jump into it. Sine squared plus cosine squared is equal to what? The last time I solved for sine squared, suppose I take this now, same statements you guys are so accustomed to, identity, and this time solve for cosine squared. Write this as cosine squared theta is equal to 1 minus sine squared theta. And do what with it? Put it right there. I want to make another substitution in my original formula. So guys, let's go back to the original. I'll go it out here, guys. Here goes. This could be equal to, so in place of cosine squared, I'm going to put 1 minus sine squared here. And of course, still got minus sine squared in the red there. Select like terms, like this in a different color. This is gonna be 1 subtract 2 sine squared theta. Michael, on that handout, make sure I have all 3 versions, green, this strange looking orange, and the red, are all those listed.
Yes.
Is that true, guys? And that's all listed for cosine double theta. So which one are you going to use? It depends on what they give you. So it might be easier to use this version to get the answer. It might be easier to use the green to get the answer. It might be easier to use the orange here to get the answer. Okay. Michael, tell me, as we close this down, what type of an exercise did I ask my class to do?
Give you tan theta
Okay.
and arrange, or domain, I should say, find the exact value to do an expression.
So I gave you tan theta, and then asked you to find,
The exact value of sine 2 theta, cosine 2 theta.
whoa. Okay, this is on the handout. Hang on. Okay, did I have it written as given? Okay, given, hang on. I get remind the class given what?
Tan theta equals 4 over 3.
Hang on. Okay, that's tangent. Which is sad because this has nothing to do with tangent over yet. And,
Pi is less than theta,
oh, wait, pi is less than theta.
less than 3 pi over 2.
Interesting, that's trying to see which quadrant you're located in. And what else we find?
Sine 2 theta.
Whoa. And then I'll go back to my formula. In fact, sign up here, in the red. Okay, guys, you gave me tan, and tell me which quadrant I'm located. I'm caught between pi and 3 pi over 2, guys. Which quadrant are we talking about? Someone help me out. Is it quadrant 3? And just for a reminder, in case I need it, if I'm in quadrant 3, the coordinates, x and y, are those. May help. Now we'll find sine 2 theta. We lucked out here to find sine 2 theta, there's only one formula. There's 3 for cosine. You can use any of the 3. This one is only 1. So I gotta use 2 sine theta cosine theta if I expect to get the answer. I'll put this out here. Interesting. Wow. That's what I need. Michael, they gave me tangent, right? But in the red, I need either sine or cosine to get the answer. Okay, someone's supposed to help me. What are you gonna do? Help me out. They give me tangent. I don't need tangent, but they give it to me for some reason. I need sine or cosine. And don't fall into that sine or cosine business where math saying, Professor, you know sine is 4, and cosine is 3. Those numbers are too large for sine and cosine to exist. There must be something else. Any ideas, guys? I need identities. Now, what identities would you want to use in an attempt to get to where I want to go? We're desperate.
Secant squared.
1 plus tan squared is equal to secant squared. We tried. By the way, on that last test, I noticed almost all my students were using the identities nicely, correctly. Okay, they gave me tan to be 4/3. I'll put 4/3 in there. Got this being squared. Secant squared. 16 over 9, we'll do the math for you right quickly. I think it's 25 over 9. Let's do a little math here. Michael, I'm gonna do a square root. Now right now it's plus minus. Perfect square root. 9/3. Work out. You guys told me I was doing what, quadrant 3? So if I'm in quadrant 3 and I'm doing secant, which is 1 over x, that must be negative. I'll erase my positive sign. Secant must be at negative 5/3. I don't need secant. I need either sine or cosine. Now what would you do?
Reciprocal.
Reciprocal. So I'll put it right here, guys, flip this over, -3/5, that's cosine. This will wake you up on a Monday for sure. Finally, I have a replacement that I need. This is -3/5. Now, if anyone have an idea how to find sine, I can put it in, and we'll be finished. He gave me 1 + tan squared = secant squared. We did a little reciprocal. I love that. Now how about sine? I can find sine now. Help me out, guys.
Cosine squared plus sine squared. equals
Absolutely.
1.
Absolutely. Sine squared plus cosine squared is equal to 1. Brianna, cosine we just discovered, so let's put that in. This is sine squared plus, I think it's a -3/5 n squared is equal to 1. Yes, let me do the math fairly quickly. That's 9/25, and we'll move that over and subtract it. So 1 subtract 9/25, guys, is it 16/25? I think. Let me do the math there. 1 subtract 9/25. Do a square root. At this point, it's ±4/5. I'm going to sign, which is y. I'm in quadrant 3. So y is negative. So erase the positive sign. Sine is a -4/5. I'm going to put that in right here. Of course, I still have my 2 out front. And what that product is, that's the answer we're looking for. And you're talking about a workout. Guys, I think it's 24/25. Jeez. Done. Oh my goodness. Jeez. Michael, please tell me, watch my time here. What else is on that handout? What was I asking, or what example did I give besides this one?
Find cosine 2 theta,
Oh, we want, oh, for the same problem?
same given.
Okay, let's do that then. I'll show you something here before we take a break. That I think you will like. It's gonna cut your work down so short. I'll be finished up in no time. Okay, they want cosine what, double theta?
Yes.
Here we go. Now, cosine double theta, guys, I've got a choice. The orange, the green, the red. It's up to you, and sometimes one is preferred over the other. I'm seeing what I'd like to use here. Oh, you know what? We found sine double theta. They gave us tangent. I'm trying to think, the green, the red, the orange. Guys, does anyone have a preference which of those 3 I should use to find this? Which one? Okay, the green, the orange, or the red? You want the red, or the green, or the orange? Which one might be easier? They all will lead you to the same answer. I think what I'll do, and some of you guys may be thinking, did we find cosine earlier over here? To find the first one we were using cosine, we found cosine. Is cosine connected to this green formula? Why not use the green? You already found it. So on the green here, guys, if I want to find the answer fairly quickly, it should be equal to, by the green one, 2 cosine squared minus 1. Let's put the cosine, we found cosine to be, I was pointing to it earlier, -3/5 squared minus 1. Let me do the math very quick. That's 9/25. Oh boy, twice that is 18/25. Let's hope I did not mess that up. Subtract 1. So it's 18/25, subtract 25/25. I think it's a -7/25 when I do my math. And if that's no mistake, that's done. Now we'll have Parker check this before we leave. Get some math there. Now, Michael, did I ask for tan also, or what did I ask for?
You asked for secant.
Secant, okay, secant double theta. And with all the work you see on the board here, guys, I would quickly say, Professor, there is no secant formula over here. You write it as 1 over cosine, they are reciprocals. You know that, and then to get the answer, it's 1 over, and cosine we just discovered is this. Negative 7 over 25, right above me. I do a reciprocal here, it's negative, looks like 25 over 7, I think. I'm finished. Proceed. The truth? Woo! Mr. Park, we're closing this down, trying to get this chapter out of the way, completely out of the way. Mr. Park, would you do me a favor? Here goes. I would not dare ask my students to do this. Do inverse tan on 4/3 and see what the angle is. Inverse tan 4/3 first one. Guys, this is all check. Hang on just 1 second. What does this show?
53.1.
How much?
53.1.
53.1.
Yeah.
Now, Park, the angle is supposed to be in quadrant 3.
Mm-hmm.
53.1, the way that calculator's been programmed, it gave you the one in quadrant 1. So what are you going to do with 53.1 on the one we want, which is supposed to be in quadrant 3 there? In fact, my class plate could tell me what to do with it. What would you do with it to find the one I want? The calculator showed him the one in quadrant 1. Ours is in quadrant 3. What would you do? Someone decides the angle in quadrant 3. We're in quadrant 3. Calculator shows one in quadrant 1, 53.1. Anyone have an idea what would I do with 53.1 to make it fall into quadrant 3?
Add 180.
Add 180. So actually what the calculator shows is this little reference angle. It's showing this. If I add 180 to it, that will take me into quadrant 3. And guys, 180 plus what he gave me, Art, 180 plus that, is that 233.1?
Mm-hmm.
Okay, so the angle I'm looking for is, hang on, 233 E. Point 1, correct? Now, Park, we got that out of the way. Jeez. Okay, we'll check one of these. Now they ask me to find sine, now look at those mess. Sine of double that angle. How about double that? That's 466.2. Park, find sine of 466.2 for me. We got 24 to 25.
0.96.
0.97?
96.
Oh, 96. All right, we got 24 over 25. What's 24 divided by 25?
0.96.
0.96. I see it looks like, oh, professor. How did you go to grad school and have a math class at 8 o'clock, and a math class at 10 o'clock, and a math class at 3 p.m. in the afternoon? For all those years you were in grad school, how did you do that, professor? Have math all day. Saw something like this going on in my brain all day, and loved it. Guys, we checked it. I don't think there's anything else. Is there anything else left?
Solving an equation to 0 to 2 pi.
Oh, there's an equation. I'm looking at my clock here. Is that the last thing?
Find the exact value of cosine to inverse sine 3 over 5.
Okay. Here we go. You just take a breath. You just take a breath. Look what we've done so far. I gotta get this out of the way. Chapter 6 has got to be done tonight. I was hoping to also get chapter 7 out of the way. Now, before I do what I had to do there, I'm gonna give you a little hint on something here, and, see if I can find it. Oh, boy. We got the double equal formulas out of the way, we got the A plus B, A minus B formulas out of the way. Is there, Professor, how many other formulas are there? There's some formulas called half angle formulas. You don't have the handout for that yet. That's coming up after the break. These ones, oh, how many formulas are there, Professor? There's tons of formulas. I'm only just responsible for what you see here. Okay, guys, yes. Okay, here goes. Ooh, should I do it? Hang on. We'll do a little erasing. Watch me. I hope I don't mess up. All this is done. We did it by formulas. And Park has checked it out, and we have the right answers. Now, some of my students will come to me and say, Professor, I had trig back in middle school, high school. And all I remember about sine was opposite of hypotenuse. Did you guys ever some trig maybe back then? Right? Sine is opposite of hypotenuse. And Professor, I have not seen you use opposite of hypotenuse. You've been using y or r, you've been using formulas. What, is there a connection to that I saw earlier back in high school? Does anyone remember what cosine was back then? Sine is opposite of hypotenuse. Does anyone remember what cosine was back then? We're just going to leave it in chapter 7, which is a short chapter to finish up. Yes? Adjacent over hypotenuse. And the last one that most students remember is tangent. Does anyone remember how to find tangent back in middle school that we're not doing right now? Here. Opposite over adjacent. Now, after we get back to the break, I gotta do that. In chapter 7, I gotta go back to middle school and finish up the trig part of the course all together. But before you leave for a break, I'll try to make this short. I'm gonna make a sketch of, if we can, what the given looks like, and point out something right quickly that maybe you would like. Here goes. On the grid, the angle we're talking about here is in quadrant 3. You guys will put the angle down here in quadrant 3, where it belongs. And Park gave me the actual angle, let's just make it in quadrant 3. Now, I'm gonna form a small right triangle in quadrant 3. Let's see if I can do it and make it look reasonable. I'm gonna drop a perpendicular to the x-axis. We'll always go to the x-axis. And have my angle in quadrant 3. Now, it's caught within that triangle. Whew, let's see what I can do here. If I'm on the triangle, right now before the break, I know this must be representing y, this must be representing x on the grid. Is that true? Now, a good replacement to represent, or a good letter to represent the black hypotenuse, they call it. Usually, most textbooks use an R to represent the hypotenuse. We've been using R like a radius. By the way, guys, could I draw a circle around that, make it a unit circle, and that R would be a radius. So I got an X, a Y, and an R. They gave me tangent. Tangent is, if I'm approaching this differently, tangent is Y over X. That takes me way back, isn't it? So that means the way my sketch is here, Y over X, now I'm in quadrant 3, gotta be careful. Y is -4, and X is -3. Is that true? Y over X, because now do it with a sketch rather than a formula. We've already done the problem. The hypotenuse, c squared is equal to a squared plus b squared, guys. I think in no time, if you use those numbers there, you'll end up with a 5. C squared is equal to a squared plus b squared, 5. Is that true? And if I check it right quickly, square 5, you get 25. Square these two and add them up, you get 25 again. end of 9 plus 16 is 25, 5 squared 25. That's what that problem says. I'm in quadrant 3, tangent is 4 over 3 y over x, and the both negative, and my radius down there is 5, or hypotenuse. Lord. Whew. Now here's what I'm gonna do. To find this by formulas, did I use sine? What did they ask me to find here, Michael? They asked me to find what, sine of 2 theta?
2 theta.
Look at this. And the formula was, we used the formula, was it 2 sine theta, was it? Cosine theta, yes or no?
Yes.
Look at this, guys, and I went through all this rigmarole, all that work that we did. Here we go. Please tell me. This is not a unit circle, is it? If I actually connect and try to form a circle there, it's not a unit circle, guys, is it? I think the radius is 5. Let's change it to a unit circle since you guys are so accustomed to unit circles. How can I change that 5 easily into a 1? Look how easy this will be done. If I want a unit circle, since we're so accustomed to it, let's just divide by 5, and I'll turn that into a 1. But if I do it there, I gotta do it here, and here. That's a unit circle. Now, I need sine theta. Sine theta on the triangle there, since I'm now back to a unit circle, sine is y. That's negative 4/5. Y is negative 4/5, that goes right here. Cosine is x is negative 3/5. And of course, in the formula itself, we've got a 2 out front. And I think when you do the math, that guys, we end up with 24 over 25. Is that true? Did we have a 24 over 25 earlier? When I went through all that business with formulas, did we get the same thing? Now by using an illustration, and thinking about it a little bit there, it's done in no time. So we'll do more of this after the break here. Wow. Any concerns? Okay, I see it's definitely time for a break. A 10-minute break now. Make sure you're back in 10 minutes, because I'm going to be pressed for time tonight. Okay, as you leave, stop by and pick up your exam if you have not received your exam yet. Guys, take a 10-minute break. And we'll get the other part done after the break.